Okay, so we're now starting to get a little bit more practiced with them sketching our polar curves. So just a wee bit of advice before we go on to our next one. So most polar curves are sketched the same way. Here are some tips to help you sketch curves given in polar coordinates. Look for any symmetry. If r is a function of cos theta only, there is symmetry about the initial line. So that's effectively our x-axis. So if it's a cos theta function, there's a line of symmetry going across here. If r is a function of sine only, there is symmetry about the line theta is pi over 2, which is kind of our y-axis here. The equations r equals a sine theta and r equals a cos theta are circles. Here's our example 5, and we'll work through again. Bit of a strange way of doing this one. Find the Cartesian equation of the curve r equals a cos theta. Again, we could do a wee table of values and work out the values that it's going to be. It's a wee bit messy for this one, so we're going to try a different one. We are going to multiply through this by r. Coming up with this with yourself is a bit of a nightmare, but again with a bit of practice you'll see what happens. So if we times this by r, we're going to get r squared equals ar cos theta. We know from a few pages back that r squared is the same as x squared plus y squared, and we also know that x is r cos theta. So if we substitute those things in, so let's write out what they are again so you don't see it disappear. So we know r squared equals x squared plus y squared. We know that x is r cos theta. So we can write then this is going to become x squared plus y squared equals ax. This is a little bit messy, but if you complete the square here for this, and again, I suppose kind of take my word for it, we're not going to spend too much time doing that. We're working on polar coordinates here, so it's going to give me x minus a over 2 all squared, kind of taking this over and taking the square out, plus y squared equals a over 2 all squared. I hope you can now see that from your AS level regular maths that this is now the equation of a circle. So how do you work at the center of the circle? The y coordinate is going to be 0, and then the x coordinate is going to be center of the circle is going to be a over 2, and then the radius is then going to be a over 2 as well. So it says, and this is a circle. So the center is going to be a over 2, 0. And the radius, as I said, it's going to be a over 2. I'm going to do a quick sketch of this. I'm sure it won't go well, but here's our axes. There's our point then, a over 2, so that's our center. And of course, if the radius is on, it's going to kind of hit here. So my circle is going to look a little bit like a dodgy enough looking circle, but you kind of get the idea. So that wee distance here is going to be a over 2. And that's the way the circles work. And of course it says the equations r equals a sine theta and r equals a cos theta are circles. So in this one, r equals a cos theta. So this is a circle then of radius a over 2. Depending on how big a is, and it kind of makes this a bit bigger. If it's a sine one, we know there's a line of symmetry here, so the circle more appears in this direction here. But that's how it works out then for example 5.